So as we thought yesterday, right, we need to understand patterns first to implement uh, microservice, architecture-based applications. So first thing, we understand that monolithic means the old application architecture, the old style, having all the modules together into a single application. We learn the problems. Basically, when you want to deliver within very less time with monolithic architecture is not possible. If you try to deploy large number of teams, that will not help. Rather than speeding up the implementation, it will create a lot of confusions in the process or in the development and integration. When integrations taken place, it will create a lot of confusions, lot of testing difficulties, right? We will be having in monolithic architecture. If you have single team and if they are working for years together, it's okay. But deploying multiple times to deliver, multiple teams to deliver it in very less time, that is not possible. So in microservices architecture, that is possible. If you have any big application, right, you can have parallelly multiple teams can work with different technology stacks, and we can integrate all that microservices together. Okay, so within the very less time, we can able to deliver the application if you choose to microservice architecture. Okay, in microservice architecture, usually we are creating applications as a small size applications. Let's say, as I mentioned yesterday, if you take e-commerce application, so each module or each use case or each feature as a microservice you can implement. As small as you can implement a microservice, the first principle you need to use, I mean, your microservice should be fully functional microservice. It should be fully functional microservice, whichever requirement you pick to implement your microservice, either a use case, a module can be a microservice, and you can implement a use case as a microservice, a simple use case or a simple feature as a microservice, but it should be functional. Whatever you implement for your microservice, it should be fully functional. It should be fully functional. So if you take e-commerce with multiple modules like admin module, seller, manager, customer, delivery, there will be many users, or you may consider them like a modules. Okay, so when you want to implement e-commerce, a small scale, if you imagine, I have 5 modules here. So each module has a microservice you can implement. If that module itself is very big, let's say if you choose customer module itself is very big, I can't handle it in a single microservice. Again, I want to break it into multiple services. Yes, you can do that. For customer sign up and all, I want to create a separate application. For product search itself, I want to implement a separate application by implementing search engine capabilities. And to add cart and checkout, I want to create a separate microservice. You can create. If you think module itself is very big, you can go use case wise, or you can consider it as a feature also. Feature wise also you can implement a microservice. But finally, a microservice should be fully functional and working. It should be fully functional and working. Independently, it should work. Fully functional and it should work. A microservice when you implement. So if you follow such, if you follow these rules and if you implement it, so end of the day you will be having lot of microservice applications like admin microservice, seller service, manager service, customer, again for customer, customer search service. When I see the model itself is very big and I want to break it down into again multiple microservices, you can do it. Customer cart service, for payments you may have customer payment service, and for delivery agent I want to, for delivery tracking I want to one delivery service. Same scope, same requirement. Instead of implementing it in a single application, you can break it down into multiple pieces. So how you can break it down in the patterns? If you go in microservice patterns, so they given decomposition. How you will decompose your requirements? Decompose by business capabilities, means modules, business capabilities. So whichever is important for you and which can be independent service, how to decompose an application into service. The architecture must be stable, service must be cohesive, and service should implement a small set of strongly related functions. Service must be conform the common closure principle. Service must be loosely coupled. A service should be testable. Each service be small enough to develop by two pizza team. What is this two pizza team? Okay, two pizza team. A team is 6 to 10 people, as that is recommended in Agile, right? Not more than 8 or 9 people in a team. Each team that owns one or more services must be autonomous. A team must be able to develop and deploy their services with minimal collaboration with other teams. Means when you implement them, we should have less gap between other teams, as well as minimal communication is required. No, you should not share all your uh, you need not to share all your how you implemented. You need not to talk with them. This is what I implemented, this is what you need to implement. You should not have such huge collaboration between teams. So a service should be self and independently workable copy. And if somebody needs your information, maybe via documentation, automated documents it will generate like Swagger, via documentation they should be able to understand in case if at all they require, and they should be able to develop it. Okay, so that practice we need to learn. Otherwise we should not reach out to other teams, tell me what is your request, what is your response structure. That is not required. So less communication is required. So what they are saying, the business capabilities of an online store includes product catalog management, inventory management, order management, delivery management. So they're categorized with the capabilities. Product catalog management will maintain products. Inventory management will verify that the products inventory is sufficient or not, or do we need to order for more products or not into the store. Order management will take care of orders. Delivery management will focus on delivery phase. So each module, if you can create it as a separate service, that will be sufficient. So the resulting context, stable architecture, since the business capabilities are relatively stable. So if you go with the business capabilities, saying that architecture is stable because each is having their own different, set of responsibilities. Let's say if it is admin module, admin will have set of admin responsibilities. That will be stable. You will not get any confusion with other modules. All admin related tasks you will be having here. All customer related tasks you will be having here. If you go with this one, seller activities will be in seller only, manager activities in manager only. So very less confusion you will see going in future, and your architecture must be stable. So decompose by subdomain, why they mentioned it is, as we see subdomain yesterday, right? So uh, if you have very few domains, let's say uh, if you want to keep admin, seller, and manager service relatively if they are small, and for them if you have subdomain like manage dot amazon dot in, if this is your subdomain, manage is your subdomain. Under this manage I want to bring three applications, I mean three modules. So based on subdomain, if you want to club them as a single application, you can do that. In case if they are relatively small, I don't want to make it as a separate application, I can club them together. Relatively they are small, very less number of people will interact with them. So I need that three together, because a lot of calls back and forth I'm doing from admin to seller, seller to manager, manager to service, seller, and seller to admin. So I want to keep them together as a single application. You can do that based on your subdomain. So it's all depends on your cost, team, infrastructure, how you will decide, and the maintenance problems. If you keep all these as into consideration, you can able to create a microservice. Let's say as a module, if you want to create it, you can create it. But when you observe that, okay, why I need unnecessarily a separate server for admin, seller, and manager, relatively they are small. Daily 10 admin requests, 10 seller requests, 10 manager requests only I'm getting. Do I really need a separate service, separate team, separate development efforts, and separate server space? Is it required? What if I develop them together? I can reduce the server cost. One single server or one single services must be enough, and I can integrate with one single domain. Domains are, they are free of cost, but if you have any concerns with the domain subdomains also, I have only three subdomains. Within that three subdomains only, I want to fix my application, because they have, based on subdomain, I have information exchanging between the services. Yes, based on subdomain also you can create them, or based on modules. It all depends on your infrastructure and your team, and relatively the number of requests they are getting. If they are huge in terms of users request, and huge logic if you have, then you can divide it as a separate service. Otherwise, as you find multiple modules or multiple users, for each user I want to maintain a separate application, that really not required. If relatively small, you can club it together and make it as a single application. Okay, so that is what via subdomains they are saying here. Based on subdomains, you can read through this document. Okay, and some other capability, some other also mentioned here based on. And self-contained services, self-contained services, consider FTZO applications, which is online food delivery application. A client of application creates an order by making HTTP post request and expects a response, say within 600 milliseconds. Because FTGO applications uses the microservice architecture, the responsibilities that implements order creation are scattered across multiple services. The post request is first routed to order service, which must then collaborate with the following services. Restaurant, which means when you make a call to order, a order service will take the request and subsequent calls should go to the consumer service, kitchen service, and a hotel service, whatever you have. The multiple requests parallelly should shoot out to other microservices. So restaurant will start preparing the food. As soon as order service will get the request, it will send it to restaurant, as well as it will send a request to some other services where you want to keep your records, kitchen service, accounting service, to create your order request, transactions, and amount transactions, everything to save. And finally it should give response and it need to be executed within very less time. So self-contained services, also nothing but like your modules only. Um or you can say they have their own specific capabilities similar to modules only. Order service will have only taking orders only, and kitchen service will have a separate kitchen request they will get. Restaurant will get the restaurant orders, and the restaurant service will provide the menu and details, prices details. Kitchen service will create tickets when there is a request from the customer, and when he plays instructions like cook food with where less spicy and less salty, all that request will placed into kitchen service, so chef can able to see them and can able to cook food as per your order. So self-contained services also they are saying you can implement. Again, it depends on your application. As they are saying, if it is online food delivery application, they are like modules only you can consider. The chef needs a particular console, and from there you want to see what they order and what uh, kind of uh, instructions they have given. For chef, you can create one application to bring the restaurant to prices and menu items which are available currently. You can have a restaurant service. So once consumer places the order, to track his information and is that order really placed and accepted or not, maybe one consumer service to see your previous transactions or the current transactions failed or success, you may need an accounting service. So they are saying self-contained services you can implement, or service per team. So in case if you have multiple teams based on the business capabilities, let's say as I was discussing yesterday, you have a Java team very strong in Java based the microservice implementation, and they are really good in customer based services like accounting services, transactions, and payment services. Will be assigning that all tasks to them so that they can develop their services. And if some people are really good in accounting and other area, user experience area, for them I want to assign different services or different tasks, they can work there. And the minimal communication is required between teams via documentation. We can share the knowledge between teams, like Swagger documentation that we can provide to them. Yeah. So finally, when you decide to implement a microservice, you can implement it. You will be having all the requirements. for your requirement, you can implement a microservice. Purely microservices are REST based applications. All the services we will implement as a separate REST applications, REST based. So using HTTP protocol, we can easily able to talk with them. So you can have your backend code, pure backend code we will implement, pure backend code only we will implement here. And if you need front ends again for this backends, you can have front end teams separately. Front end teams. In front end also, if you want to create separate front end for each microservice, it's your wish. You can create separate front end for each microservice. Admin front end team if you have, then you can maintain admin front end, admin UI separately, and customer UI if you have separately. Usually big applications will have separate UIs. They don't club everything together. So customer UI you can have. If it is a relatively small, very few pages if you have, then you can have complete all the modules together into a single UI. Otherwise, you can have separate UI applications. Okay. Here I have admin UI using Angular or React on Node platform. I developed it, so it will run on Node. It will run on separate Node. Other applications also can have their own front ends here. So each microservice can have a front end. Each microservice can have a front end, or all microservices can have one front end also. Okay. So it all depends on your application size. You can break it down into multiple UIs or same UI. If you see the Amazon, right, Amazon is having different UIs. So Amazon.in is for customer, and if you see for delivery they have, for delivery people, logistics, they have different domains, logistics.amazon, and for sellers they have different domain, as we see yesterday, seller.amazon.in. As a seller you can, right? So every application they have different UI here. Okay. So different domain together, right? This domain must be loading all this front end information from a different front end server. So each microservice can have a separate front end application here. Like customer can have a separate application, admin can have a separate application, seller can have a separate application with the different subdomains. And they can talk with your backend services. They can talk with your backend microservices. Directly, we don't allow to interact. Between, we will put gateways. Via gateway only we allow them. So this is where gateway will help you. So they will place request to gateway. Just this is a mediator between your UI and backend. So from here, it will send your request to associated backend services. Okay. So gateways will help from that front to forward your front end request to backend. Gateways are important. If there is no gateway, what will happen? Your backend service URLs directly will be exposed to front ends. So directly front ends will call backends. That will create a lot of problems. If you want to centralize all requests and if you want to apply security and all, they will be decentralized. Independently, each UI will call its associated backend. So there you need to apply security everywhere. Everywhere security need to be applied. Instead of that, if you have a common gateway, all the requests will be placed to gateway first. Here you can verify security and all. If everything looks good, then you can forward your request to associated backends. So here itself we will filter out the request and we will forward it to backends. And for this backend services, okay, so that is what they are talking here in the gateway, API gateway. When you want to expose your application to external APIs, right? So backends for front ends. Backends for front end means you have backends and you have front ends for that particular backends. Each backend is having a front end. If you want to map your front end into backends via API gateway, we do that information exchange. So we place request to API gateway, gateway will place request to backend services. And configuration service, config service. If you see communication pattern, communication, querying pattern, decomposing pattern, testing pattern, observability, infrastructure. Did they mention here? No, but it's okay. Yeah. So as you have multiple microservices, if you want to maintain configurations for them, let's say imagine today you have five services and five services having their own databases. In microservices, right? Strictly we follow a separate database instance for each microservice. A separate database we will maintain for each microservice, or at least a separate schema for each microservice. We will maintain it. That will see in database patterns. Okay. So what they are saying, recommendations right here. If you see how you will maintain databases. So database management, database per service you need to maintain. If you have order service, you need to have order separate table. Altogether maintain a order database separately. For customers, you have customers tables, you maintain separate customer database. So service must be loosely coupled so that they can be deployed and scaled independently. Some business transactions must be enforced, um, span multiple services. For example, placing order usually the case must be a new order, will not execute at the customer credit limit, blah 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 blah. Whatever it is. Okay. So maintain a separate database so that what they are saying is if you can maintain separate database in future, if you want to scale up or scale down, all right, you can particularly focus on that particular database and you may scale up or scale down that particular database. Scaling also will be easy. In cloud you need not to do that, automatically cloud will do scale up for you if you configure the parameter how many you know how much you want to scale up or scale down based on the users count, it will do it for you. For customer, if you want a big database, you can maintain it and automatically you can configure for doing scale up and scale down of your database instances or number of connections so that it will speed up your process. Okay, separate database instance is recommended for each microservice as per database patterns, right? For microservice, separate database you need to maintain. In monolithic, we used to keep all tables together into a single database and all modules used to connect with it because the request coming to the same application, we will not having multiple databases, we will maintain same database and we used to connect to them. In case of microservices, we maintain separate database instance. We don't use any common database. Still, if it is internal application, you don't have any problem to maintain. You can maintain if it is very small application. But in case of large volume applications, it's not good practice to maintain same database. If you maintain same database, if you want to do scale up for a particular module, unnecessarily it will force you to increase the size for other modules as well if they are not really required also. Okay, so that is from the database point of view. And we'll talk about refactoring. Okay, yeah, remaining we will see later. So now Coming to configurations, one scenario is gateway will help you to map your front end request to backends, and your backend services. Imagine when you have lot of backend services, and if they need configurations as an architect or a team lead or a application side maintenance, if you have properties here in local itself, all the configuration properties, if you configure them in local itself, if you have all the properties in local itself, so it will be very difficult to manage them. Let's say one property is common across all the services, one property is common across all the services, so that I have coded inside my application properties file itself, so that is there inside my application itself, and I want to change it. Already I have 10 microservices, so in 10 microservices I have one common property, that property I want to change. So you need to visit all your 10 microservice applications, you need to change that property, then you need to restart your application. So if you have that common configurations, common stuff, you need not to maintain duplicates everywhere. You can have one central configuration server, there you can configure all these local properties global. You can maintain properties globally using cloud config concept. Okay, you can create a Git repository, or in a Bitbucket you can create a repository. Into that repository you can place all your properties, application dot properties, global properties you can mention here. You can create a simple properties file, you can keep all required key and values here, all your keys and values you can put here. And to read this git properties data, to read this git properties data, right, to read this git properties data in spring cloud, right, in spring cloud module they given cloud config server. You can create one microservice, cloud config microservice. You can create one microservice, cloud config microservice. This microservice can load these properties remotely. This microservice can load that properties remotely into this microservice. This one also a microservice, cloud config service you need to create. And you can point all your applications from this cloud config service. Instead of local properties, you can refer this cloud config microservice. You can read from there. You need not to make any calls, just a simple configuration you need to mention across all your microservices. So that configuration always it will go to this microservice, and it will borrow properties from there into your application. It will bring all the properties from there to your application from this cloud service. And this cloud service will read all the properties from your repositories. Still, if you don't want to configure them here, if you want to read them from some vaults, you can configure that vaults properties here. If you have key vaults, from key vaults, if you want to read them, you can read them. If I have any key vault, as I don't have anything with me, right, I'll just keep simple key values here. I'll read that values into config server, and I'll point all my microservices to cloud config service, so that it will read properties from here. I need not to hard code properties inside my application from now in my microservice. Though you don't have properties here, it will read from your repository. From repository, it will read properties into cloud config service. That config service will provide you properties into your local. But that what all you need to do is just create one repository. Let me show you example. So this is one project, cloud config service I created. You need to use one dependency here, cloud config server. Now in this project, just enable config server here. So it will behave like a config server, which will produce all the properties to microservices. So this is the common point. for all your configurations. Still, if you see, do you have configurations here means no. Configurations are reading from Git repository. In case if you have Bitbucket repository, other repositories you can find here. There are other properties given to read from other repos. Server dot AWS store, or from Azure Key Vault if you want to read MSI path, or Bitbucket you want to read. Bitbucket also should be there. Yeah, you can check these properties. You can configure Git, Bitbucket, any cloud repository you can map here. From there it will read the properties, and that properties it will make available to your local services. So for now, if you visit this path, right, I created one config server repository. There I created one simple properties file, and I have properties there. Profile configurations I configured. For dev profile, one database URL, username, password, and few JPA properties, driver name, and HBM to DDL properties, and dialect properties I have here. Simple dev and SIT properties I have here, just to connect with MySQL database. Now you can imagine all these properties instead of hard coding within your local. Now you have globally here. From here you can point to all your microservices. Wherever you want, right? You can read them. How? First you need to load this it into cloud config server. So this config server is running in 8888 port. You start it. Now wherever you want to consume it, you can consume it. Let's see if I go to one service, admin service here. You go to properties, Spring config import. Instead of having hard coded properties here, I'm just importing from config server. Config server is running in so and so host and so and so port. That host and port given here. So it will load properties from your config server. Config server is running in 888 right? From there it will load. And config server will load properties from Git repository. So now you can imagine these properties are getting loaded into your local. You can imagine that properties will be available within your local itself. If config server is down, they will be not available. So config server should always up to read your properties, and config server need to read properties from cloud repository. From there it will read your properties and it will keep it available for local. So if I show this use case to you, right, let me create new repository, a small example. Okay, maybe I'm not authorized to that repo. So create a simple repo here. Maybe this must be out of memory. It's okay. Let's use existing one only and see. So in existing one we have properties here. Let's read these properties. To read that properties, just you need to run this config server. Yeah, here I have. Just create a simple project if you want, right? Create like this. Create project, Spring Starter, my config server. Next, add config server here. Config server dependency. You can see config client, config server. Two dependencies you can have from Spring Cloud. Add this config server. Okay, bus. So config server is sufficient for me. Now finish it. So my config server is created with a properties file and one class. Just mention here at the rate. Just a minute. Yeah, it's almost done. Yeah. So just mention at the rate enable config server. com.rbu.ecom doesn't match. So I don't know. Maven update. I see there is a disturbance here from .rbu.ecom. No, it is gone. Okay. So enable config server and point to Git repository here. Server dot port. You can run it in your required port 8282, and you can configure here the Git repository path. You can just create Using this URI, you can configure path. So if you want to create any brand new Git, you can create. Not allowed there. Create a new Git branch. No, actually, I want to create a repository here. I think it went to out of space. It is not allowing. Or else you can use this same config server. You can copy this path, this config server path, and you can keep it there. Already I have repository, right? You may copy this git http path and put that here. So your properties will be loading from this git repository. So now these properties, if you want to use anywhere, right? First to run this server, my config server, started my config server. Okay. Initializing Spring embedded web context. It is initialized and no active profile configured. Default profile. Nothing to worry. Started. Welcome in config server. Okay. It is running in port number 8282. Fine. Now, if you want to consume these properties, before consuming itself, let me write one uh, command line argument or application argument. Application arguments I want to see. Implement from application arguments. Command line runner, or, sorry, directly application arguments is over. Application runner. So here I think by using what property get source arguments, right? Returns the raw unprocessed arguments that we passed into the application. Okay, these are source arguments, non-optional arguments, optional names, returns the options, returns the values, not this. Which one we used to read our properties? Uh, Optional arguments. These all arguments which we passed from command line. It is giving here from properties file arguments. If you want to read, uh, which one will give you? Sure. Okay. Let's leave this. Maybe you can write a simple controller and try to read that properties here. At the rate rest controller, private string the driver, whatever you have here right in the cloud. You may you may read them. Okay. URL we have username, password. Let's read these three properties. At the rate value annotation, and you can read them here. Mention this key, and the expectation is it need to read this value from cloud. Username, password. Username, password. So maybe from here I'll return them. Return URL plus username plus password. Service is running, shut down and restart this again. Could not resolve placeholder URL. Okay. So first profile not set here. There we have two profiles in the properties files, dev profile and SIT profile. So we need to enter profile here, which profile need to be loaded. So for that, we know we need to use string dot profiles dot active is equal to dev. It will give dev profile here, and confidently I mentioned port, but web dependency not added, right? For config server, web is not required, but as we created a controller within it, basically inside config server we never create any controller, just for checking purpose I created. What happened to you? Could not resolve placeholder Spring data source URL. It should be available, but why not here? I don't know. Within cloud config, it must be loading from here. Or else let me do the same stuff in a different application. From other application, we'll point there and we'll try to read these properties. Create project, Spring Starter, config client, I will write. I'll create a web application with the config client. Enable config, enable discovery client you need to add here. I think yes, so that it will able to read your configurations from the cloud config and point to your config server to read properties. Now let's read properties from config server. Config server is running in 828. Let me remove this class from here. Controller, I'll move here. So just to start your config server application. So just config server is started and start config client application. There we have one REST controller which is reading Spring data source URL, username, password, and we enable discovery client to enable config client and reading configurations from config server and running it in 9090 with the profile dev. Run this application as well. So this one also started 9090. Now call localhost 9090 slash get data URL. You can see URL and appended username, password, the same which you have here. The same which you have here. Let's say if you rename, change them. Is it allowing? Just a minute. Default 750 MB they provide. I think I exceeded that limit. So that's why it is struggling. Okay, leave it. So you are getting data of dev properties. So dev properties, whichever you have, we able to read that data here from this application properties file. So if you read SIT, right, SIT configurations, then it will give data from SIT. So you may shut down this and your profile you can set it to SIT now. So from cloud config it will read SIT properties. Earlier schema is simple admin schema. Now if I refresh it, you'll be getting admin schema SIT. So your SIT properties are getting reading. So this URL and all it is reading. So what I want to tell you from this is you can have a centralized configuration server as you have multiple microservices. If you do configurations locally, when you want to do the changes, it will become very difficult. or maintenance of your passwords, URL, usernames, configurations will be very difficult when it is composed in local. Instead, if you have all your configurations in a centralized server, as an admin, if you have permissions to this, you can go here and you can modify your properties whichever you want in future when modifications required. So that's how we need to centralized configuration server. Okay, we will see gateway tomorrow. We'll explain more about gateway and we'll give you example. Okay, yeah. To see the properties through actuator, I think we can see metrics, some properties there. I'll check it out. So just you want to see what all properties available there, right? Hmm. Correct, correct. Yeah. Mhm. I think in actuator they given metrics something. Yeah, yeah, I think metrics. If we can add actuator here, let me do that. Okay, as actuator will help you actually from many points. If I add actuator here, right? Spring add starter. Basically, actuator we use to monitor health, and there are some important metrics URLs also they given. Let's see what are all provided. So simple actuator service added there. Actuator dependency. Now if I start my application, is it in actuator or dev tools? I'm not sure. Let's see with actuator. So configs reload. Hmm. Live reloads it will do. Yeah. So actuator is now enabled for this application. Localhost 9090 actuator. So some default links it is showing. I have not implemented any endpoint for actuator, but this is default actuator. Uh, endpoint will be available. So it is showing a few links here. Like when you type health, it will show the health. Uh, and there are many actually given. Actuator, actuator slash health. So it is showing your application health, whether application is up and running or not. And actuator slash something metrics. Let me see what all actuator endpoints are available. Actuator endpoints list. So there will be many audit events, beans, caches, conditions, environments, uh, flyway, health, HTTP, trace, info, logger, metrics, endpoint by default availability set. Since endpoints may contain sensitive information, careful. consideration should be given when exposed to them. So you may use info, it will give complete information. Actuator slash info. I think we need to enable them. We will see it in other session, okay? Actuator and everything. Simple miscellaneous concepts. Hmm. Yeah. Here in config server or in config client. Yeah, yeah, I added a config client dependency. During creation, I added Spring Cloud config client. Like for server, we added cloud, yeah, Spring Cloud starter config. This is cloud client, config client. For server, we added Spring Cloud config server. It depends. If you want a separate service for each cross-cutting service, you can create it. Or else, if you want to club them together into gateway itself, you can put it. Okay. So within one application, if you want to handle security, logging, you know, you can have one gateway application. Within gateway, you can handle it. Okay. Or else you can have a separate log service, separate security service. From gateway, you can make call to that gateway and logs, and you can write logs into log service, and from security, you can verify security. We will see, okay, with all possible approaches. Yeah. So the main thing you need to digest microservice architecture. Well, we need to, you know, um, change our thought process from monolithic to microservices. We need to adopt so many practices here, like when you try to create them, how to create microservice, how to maintain databases, how to put read operations or write operations, right? Again, for read and write operations, they given different patterns. To maintain databases, we have database patterns. To create microservices, they given patterns. And to maintain configurations and all such stuff, centralized servers we need to use. Okay. So for now, we learned how to create microservices, simple microservices with the cloud config. Tomorrow we'll see gateway. Okay. And actuator and dev tools also we'll see in tomorrow's discussion. Okay.